Okay, this is seventh grade lesson 3.8. It's actually part 3. This is working inverse variations in real world applications. So we're going to be working some story problems and understanding where inverse variations may actually occur. So here it says the graph shows the number of hours, Y, that it takes X workers to paint a room. How does Y change as X increases? B says how do X and Y show direct variation? And C, how many hours does it take for 5 workers to paint the room? So as we look through this, first of all, looking at letter A, says how does Y and X, how does Y change as X increases? So if we were to look at this, as our X numbers go up here, what's happening to our Ys? Well, if I were to just pick one, let's say we looked here, that would be 2, 4. If I check the next one would be here, so that would be over to 4, up to 2. So here's my X's and here's my Y's. So what's actually happening to those? Well, as our X's go up in size, our Y's go down in size, so they decrease. Okay, now looking from the picture, most of you can identify whether it's a direct or inverse variation, and this would be an inverse. We could also use the little table here that we just did. As one went up, the other went down, so this would be an inverse. And letter C, how many hours does it take for 5 workers to paint the room? So if we have to work through 5 workers, well, we could use the graph, but the problem is here's where it would be. So it's falling between 1 and 2 hours, so I could approximate it, but we need to really go through and actually identify. So what we're gonna do is we're gonna go ahead and substitute in 5 into our equation. So here's the equation that we have. They've already written out or solved that equation for us. So Y equals 8 over, now our X was our number of workers, so I'm going to substitute in a 5 where my X was. Okay, so now Y equals 8 over 5, which if I go through and divide that out, let's see, Y would equal, 5 would go into 8 once, and there's 3 left over. So 1 3/5 hours, which would be the same as 1.6 hours, either of those would work. Okay, so that was working to get Y by itself, which we had already done. And we said it would fall between 1 and 2 hours, but they wanted the exact amount. So it would take a little over an hour and a half for those 5 workers to paint the room. Okay, so let's try another one of these. Oh, so here I need to pull that graph back out. Okay, so the question says, how many hours does it take for 3 workers to paint the room? So looking at our graph, 3 workers, once again, it's falling between 2 and 3 hours, but they would like the amount of time. So we'll use this equation again, and we'll substitute in a 3 where our X is. Y equals 8 over 3. So if we change that into a mixed number, Y equals 3 would go into 8 twice, which would put us at 6, so we have 2 thirds. So Y equals 2 2/3 of an hour. And 2/3 of an hour would be like 2 hours and 40 minutes, if you want it with the minutes. Okay, either of these would work. Okay, so once again, that was just working that equation and substituting in. All right, so here's the next one. This time we're working off of a table. So we have, the table shows the time that it takes to bicycle 12 miles at various speeds. Does the time t vary inversely with the speed s? If so, write an equation that relates t to s. So let's go ahead and compare our x's to our y's. Now I like to look at it in terms of x to y, like side by side. So let's see, as this is, I'm going to just rewrite this table, 12, 6, 3, and then 2. And the speed was, does the time t vary inversely with the speed? So then 1, 2, 4, and 6. So when we look at this, our speed here, as the speed went down, so we got slower, our time went up in numbers. So as one went down, the other went up. So this would be, yes, it would be an inverse variation. They also would like us to go ahead and write an equation that relates t to s. So we're going to plug in our information. Okay, so our t to s, so this is our s and this is our t. So we'll go ahead and substitute in some numbers, so our x's and our y's. Okay, so our equation normally is y equals k divided by x. So we'll substitute in. Our y was a 1 equals k divided by 12. So then times 12 times 12, we find out that our k equals 12 times 1, which is 12. So our equation is y equals 12 divided by x. Oops. The last part says, what time corresponds to a speed of 4 miles per hour? So they didn't include that up here. They did not include the 4 miles per hour. They went from 6 to 3. So if we were to substitute in a 4 where x is here, y equals 12 divided by 4, y would equal 3. So that would be our speed, 3 miles per hour. Okay, so that's using our equation and solving for a missing factor for letter B. All right, so let's go ahead and try one more of these. Actually, I guess that's it. I don't have any more. So that's it. That's working some real world applications. Good luck with these, and just remember that your inverse variation is y equals k divided by x.